Wow, this thing is unbelievable. Hey guys, today I am super excited for different reasons. This sad looking contraption with some flat sheet metal just kind of sitting on my wood stove with a box fan blowing on it is how I've been trying to heat my wood shop for the last few years. It will barely take the edge off if it's cold out. Today I'm going to build essentially a box around this. I'm going to use this fan that used to inflate a bouncy house that my kids had. And to fabricate it all, I'm going to use this brand new laser welder from Xlaserlab. This is the X1 Pro. This will cut, weld, and clean multiple kinds of metal: aluminum, steel, stainless steel, copper, bronze. I saw this in a Kickstarter program a while back. I saw a prototype version of it. It looked really promising. This is the consumer available product. I've got the wire feed, the laser controller, the gun, of course the goggles, and I am really excited to show you guys how this thing works. So heavy. Now, I made kind of a big mistake when I installed this wood stove. I went straight out the back with the stovepipe. I should have gone up as much as I could because I'm just shooting heat right out the wall. I'm going to make kind of a saddle that sits over this. It'll be like a plenum using scrap metal that I got laying around. And I'm going to put probably some variation of some tube steel on the top so that when the fan blows in from the side, air will be able to swirl all around the wood stove itself, and then it'll be forced out some of these tubes and actually force hot air into the room. And it should go a long way to helping me heat this place up. So the first thing I'm going to do is gather up all of the bits of metal like this that I think I'm going to use and get them in here and kind of get an inventory, and then my design will go from there. Now I'm kind of making this up as I go along. The first thing I'm going to do is cut out a rectangle piece to sit right on top of the wood stove. Then I'll make some side pieces. This is the thickest gauge I have. It's about 3.5 millimeter. They claim 3 millimeter cut ability. I've seen people cut up to 6 millimeter thick, so twice as thick as this, so it should cut through this no problem. I'm going to lay out my rectangle and hook some air up and fire this thing off. Now, when you're cutting with a plasma torch, you obviously want to be aware of what's below the piece you're cutting because you'll have the slag and the hot metal blowing out of there. With the laser, once you cut through, that laser beam will go until it stops. So wood, flammable items, your concrete floor, they can be damaged or ignited if you're not paying attention to where your beam is going. So I've got a piece of metal under this. I've got it held up by a couple pieces of 1-inch square tube, and I think I'm ready to cut my first piece. Now, I do have the wire feed attached to the gun right now, so I'm going to quickly disconnect that because we won't need that for the first little bit here. I'm going to start around 50 psi, just regular compressed air. We'll go from there. Hit the power switch on the back side of the machine. Now this will run on 110 or 220. I have it set on 220 and it only draws 16 amps, which is pretty awesome. So you've got your welding mode, cutting, cleaning. We're going to go cutting. It's going to tell you to be careful not to shoot straight up and down because it's possible the beam can shoot back into the gun and damage the lens that's in there. So it just wants you to confirm that you're going to hold it at an angle. There are multiple emergency switches. There's this one here. There's a remote magnetic switch. Does the same thing, you just tap it. You have a key that you can lock this out so that nobody who doesn't know how to use it properly can use it. You can see the e-stop. It wants me to reset that, but we're going to hit the power. We're going to confirm, and then we're going to go to our settings. The monitoring system will tell you anything that you don't have. So it says e-stop reset. My magnetic e-stop needed to be reset. So now let's hit the reset. Everything's good to go. Hit back. Power is 100%. Frequency at 1000 hertz. Duty cycle 100%. Now you can see this connect is red. I'll show you what that is here in just a second. You would conventionally call this a ground clamp. And what this does is it completes the circuit sort of like a ground does on a conventional welder. You've got a beam that you can see, but this is not the cutting beam. This just shows you where you're aiming and your focus. I've actually got a welding tip on here. I'm going to switch this out for the cutting tip. All of these consumables were included. I'm going to go ahead and shut the machine off while I do this, just in case. And here is our cutting tip. It's got a fine nozzle that will force the air through to help assist with the cut. All right, I've got my square here as a guide, and if you were going to do this with a plasma gun, there's no way you would use your aluminum square as a guide if you cared about it, because you would likely melt this. The laser came with these goggles that are specifically designed for the frequency of laser that's used in this. It's a 700 watt laser. I can clamp this to the metal, but I've seen in other videos where just clamping it to the gun works better in case you come across rust on the metal and it doesn't make a good contact. It just cuts better if you do this, so we're going to try that. So we're all ready to go. Here's my first cut with the X1 Pro. I wanted to slide this forward because I was afraid it was going to come off and shoot into my tool cabinet here. Boy, I don't know, can you see that? That kerf is non-existent. Yeah, guys, that is definitely cut through, and talk about straight. I maybe could have gone just a pinch slower, but wow. First cut, not bad. Not mad at that at all. Wow. I said it before, I'll say it again, wow. I mean, I don't think a pencil would draw a line that fine. And there's no heat. So I'm going to go ahead and just hit that with a flapper wheel on all my edges and continue to figure out what my plan is here. All right, well, I want to have something like this on top, heavy gauge. And I was thinking, you know, I'm going to have airspace here. And instead of just having that a place for air to swirl around and heat up, I want to put another outlet down here that will act as the spacer for my outside panel. I need to cut this to length, and I also need to put a kind of a spot in it so that the air can be forced in through the back and then shoot out to the front. Like butter. I think I forgot to hit record for the rest of it, but it was equally buttery. That's gonna work. I'll have a sheet on the outside and something to block the end there. Cutting this square tube with that laser is easier than, and faster, I think, than cutting with the portaband. Definitely quieter. All right, I'm going to make a cut for the top piece, and then I want to show you something that I think is kind of interesting. If you look at that cut, that's laser. This is my plasma. And I've got a good plasma gun, but there is no comparison. All right, guys, well, I've got pretty much everything I need cut. It's time to get set up for welding. I have kind of a temporary setup running compressed air for the cutter. So I'm going to undo this and get this blue line hooked up to my argon and get my pressure set and get ready for welding. Now, I've never set up a flow meter on a compressed gas tank before, but there's a setting that makes it easy to do, and that is this gas button. If I hit that gas button, it's gonna allow gas to flow through the gun, and that will allow me to set up my flow rate. Looking for 15 liters. Up here we can select our material that we're going to weld. That's stainless steel, carbon steel. I'm not sure. I think that's one of these is galvanized steel. That's aluminum. I'm not sure what the other ones are. And then you have your thicknesses over here. So we're going to go carbon steel. We're going to go 3 millimeters thick. And it automatically sets up the settings. I'll explain what all of these mean. Power is obviously the power of the laser. Swing frequency, when the wire is coming out into the beam out of the bottom of the gun, the laser beam swings back and forth across the wire to melt it, and that 32 hertz means 32 times per second that it swings back and forth. The swing width is how wide it swings, and you can go up to 5 millimeters wide. We're going to try out these initial settings and make adjustments if we feel like we need to. But first I need to reattach the wire feed to the gun and change the tip to our welding tip. So first we'll shut the machine off. Just a simple Allen head bolt. Now we have several different tips for welding to choose from, and I'm going to start with this one. It's specially designed for doing outside corners, so that's where we're going to start. All right, I'm going to turn the machine back on and feed out some wire and make sure that everything's lined up correctly. You want to make sure the beam is right on your wire, and that looks perfect. All right, well, as far as I know, I should be ready for welding. Okay guys, this is my honest to goodness first time pulling the trigger on the welder with the wire feed. I've literally not tried this once, so this will be my first try to do a tack. Oh, I gotta turn the gas on. Looks pretty solid. I think continues. I'm going to turn up the wire speed from 9 millimeters per second to 12 millimeters per second. Oh, you know what? I didn't turn on the wire feeder. There we go. Now we'll get some wire out of it. That's just fusing the metal, which is actually, that actually might be the way to go for tacking. Let's try it with the wire feeder turned on. All right, I don't think I've got my flow. I think I need to turn up the flow on my bottle. I'm not gonna lie, that's a pretty nice bead. The wire coming out of the machine automatically pushes you along, so man, that's really good. I'm gonna tighten up that far end, get it tacked. Gotta figure out how to get that wire to not stick when I release. Oh my gosh. Not bad for the second bead on this welder I've never used before. I mean, you can't screw it up. All right, I hit this with the wire brush, and look at that. That is TIG quality at MIG speed with laser power consumption. I mean, it is the best of all worlds. Much better than my first attempt. Man, look at that. All right, well, there's nothing left to do but keep doing it. I'm gonna keep doing it. God, that is unbelievable. The way that those prongs center the focus is just, I mean, there's no skill involved, obviously. Awesome. The plan is coming together. All right, well, it was going really good at first. That's better. I think I was laying the gun down too far, and I gotta keep it up at a more of a steeper angle. Yep, that was definitely the problem. I was laying the gun down too far, and I need to have it not 90 degrees to the material, but a lot steeper than I was. So yeah, that's perfect right there. Wow. All right, now we're cooking. Oh my gosh. Look at that weld, you guys. That looks like a professional with a TIG welder just laid that down. Unreal. Wow. This thing is unbelievable. Are you tired of me saying it yet? Lasers. Almost seems like every time I weld a piece of steel on this thing, it gets heavier. Yep, getting heavier. Well, believe it or not, it's starting to look like I imagined. Unbelievable. I love it. It definitely prefers a nice tight joint, but it is possible to fill in little gaps. The wood lathe in the background should tell you about all you need to know about how easy this thing is to use. Guys, look at this corner weld. All I did was just give it a light brush with the wire wheel. I mean, that is unbelievable. There's no extra work to do. All right, well, I got that side on, the top's on, the back's on. I just need to get this side built and installed. If this thing hasn't made any sense to you, hopefully it's starting to come together now. Once I get a panel on this side, there'll be a port for the fan to attach, and this will all be sealed. So basically it's gonna force air into this chamber that will be able to shoot across the back, blow down the other side through the hole that's in the top of that square tube to come out here, 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 and then you can see that hole there to come out the front there. Boy, I don't know, I got pretty high hopes for this thing. My fan I turned on yesterday, and I probably should have known this, but it's going to be way too much air. So I've ordered something that I can adjust the speed on. It'll be here in a few days, but for now, for testing, we'll be able to use this. So I've got this panel cut. I need to make a port on it that I can attach my piece of ducting here. I'll hose clamp here into the fan, and we should be ready to test this thing. All right, well, I'm set back up for cutting. I just retracted the wire a little bit. I'm gonna leave the feeder attached, change the tip to the cutting tip. I've got compressed air running to it now instead of gas. I'm gonna cut this circle out. Instead of explaining everything, I'm just gonna do it and show you, and it'll make a lot of sense when I'm done. Look at that rust. This happened on a job at the coast. I just left this sitting outside overnight one night, and that was a brand new pair of pliers. Got an idea. All right, guys, I want to debunk a couple of things I saw that had me worried in other review videos. One is that you can't fill a gap with this, and that was probably about a 3/16 of an inch gap. And then the part that really impressed me is on the tight side. I never would have got my MIG welder in there to do any kind of a decent weld. I made a couple of passes here, but I am super impressed with how tight I could get in there and get a nice bead laid. All right, well, should just be some finished welding here, and we'll be ready to try this thing out. Like a glove. All right, I'm gonna get this fire ripping and see what happens. All right, she's ripping pretty good. I can still, it's warm, but I can still touch the top. And it is 50 degrees in my shop. It's about 6 or 7 minutes after 1 o'clock. I'm gonna fire up the fan and see how much this place warms up in a half an hour. Not much coming out of these two. Yeah, so I'm getting a lot on this, and this, but not so much on these. 107, 137. Been running for 30 minutes. It was 50 degrees when we started. Gone up 9 degrees, almost 10 degrees, and the humidity has dropped a lot, which is helpful. I think that's a win. I have no insulation in my ceiling. I've got a cold concrete slab and 320 square feet of room. Big win. All right, guys, I'm not gonna lie. When I was offered this machine to review, I was pretty skeptical. I watched a lot of other videos, and I'm not sure where some of these other guys are coming from because they seem to point out shortcomings that I didn't experience. My big concern was being able to weld gaps, and that's 100% possible. I'm really impressed with this machine with how quiet it is for starters. It's so much quieter cutting with this than with a plasma torch that's running 90 psi. I don't know what volume of air, but it's super loud when you're cutting with a plasma. This thing is super quiet, uses very little air. You could probably run it off of a smaller air compressor. You wouldn't need a big stand-up unit like I've got. Same with the welding. When you're welding with a MIG, it's a fairly loud operation. It's also drawing 30 or 40 amps of power, whereas this on 220 is only drawing 16 amps. I purposely showed you guys my first welds, my first cuts, my first rust removal. That was awesome. That's going to come in really handy for weld prep. This thing is motivating me to get back to work on my Chevy, which I know a lot of you guys have been waiting for. I'm also really looking forward to trying this out on stainless steel and aluminum. As far as this machine for a beginner, I don't think it gets any easier. I think if AI was a welder, it would be this. It makes everything so simple. Even if you don't know anything about welding, the settings, it self-selects the settings that it thinks will work the best. You can play around with those as you get to learn how the machine works. I'm still learning how the machine works, but from what I experienced, the settings that the machine sets itself on work pretty well. There's just minor tweaks. That being said, the more time that I spend with this, I know that the better I'm going to get, and I honestly think that this is a really awesome machine that does a really great job. I mean, obviously you saw my third weld, it looked like a computer had done it, so this is definitely the real deal. I would like to thank the folks at Xlaserlab for giving me the opportunity to try this out, show it to you guys. You're definitely going to be seeing more of this in future videos. If you got questions, go ahead and shoot. I'll do my best to answer them. I'll put a link below to this machine so you can check out the website and learn more and learn how to get one for yourself. Well, guys, as always, I hope you enjoyed this video. I appreciate you hanging out with me and watching it. It's actually Christmas Day right now, so I'm going to get cleaned up and go in the house and watch my children wander around with their VR headsets on. Thanks again for watching, guys. Stick around. We'll see you soon.